Hello and welcome. In the video, we'll be doing question 4, and question 4 is organic chemistry, intermolecular forces. So let's get straight into it. So a laboratory technician is supplied with three unbalanced and unlabeled bottles containing alcohol, an aldehyde, and an alkane, respectively, of comparable molecular mass. She takes a sample from each bottle and labels them P, Q, and R, right? So remember, this lab technician didn't know what was in those bottles, right? But they knew that okay, one of the bottles has an alcohol, one of the bottles has an aldehyde and an alkane, but they just didn't know which bottle, right? Because the bottles were unlabeled. So let's go now and look at the other information we have here. So in order to identify each sample, she determines the boiling point of each under the same conditions. So she just went on to determine the boiling points of all these compounds, right? So uh, these are just different organic compounds, right? So this now we have a table drawn there, and on this table drawn we can see the boiling points, right? We can see the boiling points of each and every compound there. So it was found that compound P, it has a boiling point of 76, which now the other one has got a boiling point of 36, which is compound or the sample R, or the sample Q, and then the sample R has got a boiling point of 118, right? So from this investigation, right, let's do the first question. From this investigation, we have to write down the independent variable, right? So remember, the independent variable here is the sample, right? Because the samples are not depending on anything, but the dependent variable, it's going to be the boiling point. So 4.1.1, the independent variable here, it's the sample, right? So we can write the sample, we can write the homologous series, right? Because those compounds were organic compounds, and then they were having the same molecular formula and the same molecular mass, right? So I think sample would have been the best option here, right? But it's fine. There could be other independent variables in there. Let's just move on to the next question. The next question is dependent variable. So the dependent variable, like I said, it's going to be the boiling point, right? And then let's move on to 4.2. 4.2, from the passage above, write down a phrase that shows that this investigation is a fair test, right? So do you think this investigation is a fair test? If so, then why do you think it's a fair test? So it is a fair test because this experiment or this boiling point were determined under the same condition. So that is a phrase that indicates that this was a fair test. So it was done under the same conditions. So under the same conditions, right? And the fact that also the molecular masses were comparable, it shows that it's a fair test, right? Looking at the results here, because those molecular masses were comparable, right? But the best solution or the best answer for this one would be under the same condition. So let's look at 4.3. 4.3 now. Which sample P, Q or R is the alkane. Remember, we have an aldehyde, right? Alcohol and an alkane, right? And remember, an alkane is going to have the lowest boiling point because of the weakest forces, right? So which one has got a strong intermolecular forces here is the alcohol. So alcohol will be R. So our sample R should be the alcohol because of the highest um, boiling point. And then Q, it's going to be an alkane. And then P would be an aldehyde. Because remember, on this aldehyde now, we would be having the okay, it's not necessarily the lowest or the highest boiling point, but it's just in the middle, right? Looking at the types of forces, right? So alkane has got the weakest forces, so it will have the lowest boiling point, and an alcohol, it's having hydrogen bonds, so it will have the highest boiling point. So now 4.3.1 here would write out the alkane. It's going to be compound Q, right? So 4.3.2 to answer the question, and alcohol would be R, right? The simple R, right? Or the compound R. So 4.3.3, refer to the boiling point, refer to boiling point and the type of intermolecular forces present between alcohol molecules to give a reason for the answer in question 3.2. So you have to refer to the types of forces, right? So the boiling point there. So R, it has a highest boiling point. So R has a highest boiling point, right? Why are we saying that? Because remember, since R is having the highest boiling point, we would say we are looking at the strength of the intermolecular forces, because compound R, it's alcohol. So another point, it's strong. Say alcohol has stronger intermolecular forces, right? Since alcohol consists, so you can say since it consists of hydrogen bonds between molecules, right? So remember, we're saying that compound R is alcohol, which is having the highest boiling point, because alcohol has got the stronger intermolecular forces since it consists of hydrogen bonds between the molecules, right? So the hydrogen bonds are the strongest intermolecular forces, right? So let's look at 4.4. So the alkane is identified as pentane. So that alkane there, they did some test there, and it was found that it was pentane, right? So, well, the boiling point of hexane, so now we're comparing hexane and pentane. So now we have to read the question carefully so that we know how we should answer the question, right? So will the boiling point of hexane be higher or lower than that of the pentane, right? Remember, now when we have hexane and pentane, we know that hexane, it consists 6 carbons on the longest chain, right? And in this one, it consists 5 carbons, right? So now we would say it would be lower, right? So we're expecting that to be, higher than, because hexane has got more carbons on the longest chain, right? So we'd say the boiling point would be higher. Remember, a compound that is having a higher or longer chain would have higher boiling point. So the longer the chain, the higher the boiling point, right? So we'd say higher than. So we have to explain this taking a look at the molecular structure, right? The molecular structure would mention that, okay, hexane has a longer chain than pentane, right? And then we can also mention the difference. We can account for the difference there for our answer looking at the intermolecular forces. So we can say hexane consists, hexane has stronger intermolecular forces. Right? Search there because it's just NE. I'm very sorry about that. So yeah, it has got a stronger intermolecular forces there. So now we can take a look at the energy, right? So how about the energy? What can you say about the energy? So you can mention that hexane, it will take more, so it requires, right? Never mind my writing here. I'm just doing the points. So that's the first point, and that's the second point, and this is our third point looking at energy. So it's say more energy required. More energy required to overcome or break the intermolecular forces. The intermolecular forces, right? So I think you guys understand there that here this was just a comparison, and this comparison was we're looking at the longest chain. So don't forget that next time here, if we have two compounds that are falling under the same homologous series, so we'll compare them looking at the chain, right? So they will have the different boiling points if they are having different chains, right? So here you would say it's higher than, right? And then you'd mention those points there because hexane has a longer chain than pentane, and then hexane has stronger intermolecular forces, right? And then more energy, so it has to be more energy, right? Sorry about that. It's more energy required to overcome or break the intermolecular forces, right? Or to overcome the bonds, right? So I think it's perfectly fine with this question, and I hope you learned something. As you can see that here there was no any kind of calculations, but we were just explaining. So you have to know how to explain, you have to know your theory to be able to engage with this section of chemistry, and then you'll be perfectly fine and collect most of the marks. Right, I think it's perfectly fine with this video, and